Okay, this is outcome 31, and this video is going to deal with the pH of a weak base. So I'm going to pick 0.200 molar CH3NH3 solution. Okay, and so, or CH3, excuse me, I made a mistake there, CH3NH2 solution. So the first thing to do is identify it, and of course, since I told you in the beginning that this was a weak base, that's what it is, but you're going to have to identify it on the exam, because we're not going to tell you. It's either going to be a weak acid, weak base, salt of a weak acid, or salt of a weak base. So this is a weak base, so the reaction that undergoes is CH3NH2 plus water. And I hope everybody knows this is a double arrow, so it's a weak base. Gives us CH3NH3 plus OH. There's a bunch of aqueuses that I'm not putting in. And again, we do our ice table, initial, change, equilibrium. Okay, so initially we have 0.200. And we don't care about the water, so put a dash. We'll talk about that in other classes. And we have 0 here, 0 for the hydroxide, which I forgot to charge on. Bad me. Okay, so then some amount of this reacts, and we don't know how much because it's not 100% reaction. So we get minus X here, we get minus X here, X forms, and X forms. This is because it's all 1 to 1. 1 mole CH3NH2 yields 1 mole of this, the CH3NH3 plus, and 1 mole of hydroxide. So X moles of CH3NH2 will yield X moles of CH3NH3 plus and X moles of OH minus. So at equilibrium, I get 0.200 minus X here. We don't care about the water, there's lots of it, and we get X and X. Okay, so this is really simple ice table. They'll get more complicated in other aspects. So we'll put a little box around this because I'm going to keep that, and I don't want to inadvertently erase it. Alright, so the first thing to do is figure out our concentrations of these components. So once again, now this is a base, so we use Kb. It's really an equilibrium constant, but we give it a special symbol Kb, which is the concentration of the product CH3NH3 plus times the concentration of OH minus divided by the products CH3NH2 times the concentration of H2O on the bottom, which is, you should know this, 1 because it's a pure liquid. Alright, so now we look up Kb. Kb for this base, methylamine, so Kb is equal to 4.38 times 10 to the minus 4th, which is equal to X for CH3NH3, gotten from right here, and X for the OH minus, divided by 0.200 minus X for the CH3NH2, the methylamine. So this becomes equal to X squared over 2.200 minus X. Boy, let me put a line in there to separate those. Okay? So that's what we have. Now we do our assumption. We're going to assume that this reaction proceeds very little. So I have 0.200 minus X, and I assume, and I need to write this out, and you will too, assume 0.200 minus X is about equal to 0.2. So we'll make that assumption. So our Kb becomes 4.38 times 10 to the minus 4 equal X squared over 0.2. That's coming from here. So now I can solve. Let me solve that on my calculator. When I solve that on my calculator, I get X equal 0.0094. Okay, so now, was our assumption good? So if I take and plug back into our assumption, 0.2 0.200 minus x is equal to 0.200 minus 0.0094, I get 0.191. And so this is actually turns out to be a good approximation. You might say it's borderline, but you have to make a decision. We'll talk more about that in class. I'm going to put borderline down here. Okay, borderline, good assumption. All right, so now we have our values. I got to stop and erase here. Okay, so now we have x equal to 0.0094. But notice that x is a concentration of OH, so we need pH. That's what we're after. So I'm going to do it this way. There's many ways to do this. I'm going to say pOH equal to the negative log of the concentration of OH, which is equal to the negative log of our x value, which is 0.0094. In fact, I probably ought to say up here that this is equal to concentration of OH minus. So my pOH is the negative log of 0.0094, and I get 2.027 for the pOH. And then I can use the equation pKw equal pH plus pOH. That's from the previous outcome. So the pH equal pKw minus pOH, which pKw everybody knows is 14 minus 2.027. So gives us a pH of 11.97. Just what we expect for a basic solution. pH is greater than 7. Okay, that's that one.